Okay, so this is circle geometry. So we are going to solve this question using theorem 12, right? I will explain theorem 12 in a bit, right? So let me read out the question. The question is saying that three circles with centers Q, P, R touch each other externally, right? So we have center this circle, center R, this circle, center Q, and this small circle, center P, right? Touch each other externally, which means we have points of contact. This point of contact and this point of contact. So in brief, the question is now saying that find the radii of all the circles R, Q, and P, the small letters now. So we are supposed to find the radius of this circle, the radius of this circle, and find the radius of this circle. Given that RP, right? RP, right? This entire line is 8 centimeters, and RQ is 9 centimeters, and PQ is PQ is 5 centimeters, right? So you should note this. You should know this right now. So this entire line, not the radius, the entire line is 8 centimeters, right? And this entire line, RQ, is 9 centimeters. And this entire line again is 5 centimeters. The entire line. But the radius of circle R now is from here, to the point of contact. From the center to the point of contact is the radius of this circle, right? Circle R. And the radius of circle Q, is Q to the point of contact, right? And again, the radius of this small circle is P to the point of contact here. From here to it is the radius, which is represented by the small letter P, right? So what does theorem 12 say, right? Theorem 12, what does it say? So let me bring about theorem 12. Before we get into the video, let's do our usual YouTube tradition. Subscribe, then with that being said, let's get into the video. Okay, so theorem 12 is saying that when two circles touch each other, whether internally or externally, the two centers and the point of contact are always collinear. So what does that mean? So it means that, let me explain that. So it means, let's say, so for the moment, ignore the small circle, right? Let's say we have two circles, this circle and this circle. They have this point of contact, right? So the circle centers, this center, and the point of contact are collinear, meaning that they lie on the same line. So if we ignore the bigger circle again, we will see that this small circle, right? The small circle and the slightly bigger one, right? Their centers and the point of contact are always collinear, right? So that's what theorem 12 is all about. Okay, so let's answer the question now. I'm going to require you to pay acute attention, right? So because this could be tricky, right? So the question wants us to find the radius of each and every circle, right? And from the point of contact to the center, that's the radius. So if you notice, the radius of this slightly bigger circle is Q, right? And which means from here to here is Q, right? And from this point of contact, right, to, okay, let me take a marker, right? So from the point of contact, right, to the circle center is Q, the radius, right? And also, if we go to the bigger circle, from the point of contact, whether this point of contact or this point of contact, right, to the center is radius R, right? So the way you go about solving this question is quite tricky. So I want you to pay more attention. Right. So let's solve the question. So now that I've explained the diagram, let's answer the question now. So the question is saying that RQ is equal to 9 centimeters. So from R to Q, this entire distance is 9 centimeters. So therefore, RQ is equal to the radius of the bigger circle plus the radius of the smaller circle. So the radius of the bigger circle is R plus the radius of the smaller circle, which is Q, is equal to what? To 9. That's what this means, right? So R plus Q is equal to 9. Okay, let's proceed again. And we have RP is equal to 8 centimeters. So RQ is equal to 9 centimeters. Then RP now is equal to 8 centimeters. So R and P is equal to the radius of the bigger circle, which is R, plus this radius of the smaller circle, which is P, right? So P plus R equal to 8. So R plus P equal to 8, right? Then also we have from this point to this point is still P, the radius of this circle, and from this point of contact to the center is Q, the radius of circle Q, right? So if you, from the question, PQ is equal to 5 centimeters, right? So Q, the radius of this circle, plus the radius of the slightly bigger one, unto this entire distance is 5 centimeters. So therefore, P plus Q is equal to 5 centimeters, is equal to 5, right? So we now have those three equations. So we are going to play around with these three equations until we find out that. So now we have those three equations. So we are going to play around with these three equations till we get to the point that we find out that what is the distance, the radius r of the bigger circle, what is the radius of this slightly bigger one, and what is the radius of the smaller circle. Right? So we are going to find all the radiuses of these circles, since that's what the question is saying, that we should find the radius of the circles r, q, and p. Right? So let's start calculating now. Okay, so these are the equations we have, right? So this is the first equation, right? Equation 1, and this is equation 2, and this is equation 3, right? So the first step you're going to want to do is to make r subject to the formula in the first equation, right? So therefore, if we make r subject to the formula in the first equation, r is going to be equal to 9 minus q. So this q will just fly across the equation and become negative q. Therefore, r will be 9 minus q. So r is equal to 9 minus q. So therefore, we are going to substitute r with 9 minus q in equation 2. Right? Equation 2 is saying that r plus p is equal to 8. So we're going to remove this r and put 9 minus q. Since this equation is saying that r is equal to this. So we're going to substitute r with this. So therefore, equation 2 now, 9 minus q plus p is equal to 8. So if we're now simplifying now, so if 9 flies across, the equal sign will become negative 9. So therefore, the equation will be negative q plus p equal to 8 minus 9. So 8 minus 9 is equal to negative 1. So negative q plus p is just the same with p minus q. So this is negative q and this is p, equal to 8 minus 9, which is equal to negative 1. Right? So this is now the new equation 2. Right? And therefore, we're now going to take the remaining equation, which is what? Equation 3. So equation 3 is saying that p plus q is equal to what? To 5. So therefore, this is equation 3. So basically now, this is now a simultaneous equation. Right? So here, in the first equation, we're saying p minus q is equal to negative 1. And in the second equation, p plus q is equal to 5. Therefore, you can either solve this simultaneously or using the substitution method. So I'm going to use the simultaneous method. If you solve this using the elimination method, minus here, so p minus p is equal to 0. Then negative q minus q is equal to negative 2q. I hope that was clear. So this is negative q minus, so that we have a minus and a positive here. So a bracket means what? Bracket means, okay, so if you use the elimination method to solve this simultaneous equation, right? So you just put a negative sign here, right? Therefore, p minus p is equal to 0, right? P minus p is equal to 0. The negative q, right? So this negative q minus plus q. So we have negative q, negative, positive q. So therefore, basically, negative times a positive, this will lead to a negative. So therefore, negative q, this will lead to negative 2q, right? So if you're not familiar with negative numbers and negative algebra, I have a video on that in the description. So negative q is equal to what? Negative q is equal to negative 1 minus 5. Therefore, is equal to negative 6. Minus 1 minus 5. Therefore, this will lead to negative 6, right? So therefore, divided by negative 2, divided by negative 2. Therefore, we have q is equal to a negative will cancel out a negative. 2 into 6 is equal to 3. So therefore, q is equal to 3 centimeters. Right? So if you go back to the diagram, if we go back to the diagram, right? Q, where do we find Q? So the radius of this slightly bigger circle is 3 centimeters. Therefore, Q is equal to 3 centimeters. That's the radius of this circle, right? So we're not done yet. We need to find the radius of this and this, right? Therefore, since Q is equal to 3 centimeters, we're now going to substitute everywhere where there's a Q with 3 in equation 2, right? So equation 2 is saying what? Equation 2 is saying that this equation 2 is saying that P minus Q is equal to -1, right? So where do we have Q? We have Q here. So we are going to substitute Q with 3. So P minus 3 is equal to -1. So if -3 flies across the equation, it will become a positive 3. Therefore, -1 plus 3 is equal to 2. So therefore, P is equal to 2 centimeters. So P is equal to 2 centimeters. So let's go back to the diagram. Where is P? This is P, right? So the radius of this circle P is 3 centimeters. So P is equal to 2 centimeters. Since we calculated and we found that P is equal to 2 centimeters, therefore P is equal to 2, right? So what's now the radius of the bigger circle now? So remember, when we started calculating, we made R the subject of the formula. And we said R is equal to 9 minus Q. So therefore, we are only going to remove Q and put the value of Q. So what is the value of Q? Q, we found that Q is equal to 3, right? So therefore, R is equal to 9 minus 3, right? So therefore, R is equal to 9 minus 3. What is 9 minus 3? R is equal to 6, right? And therefore, it makes sense that the bigger circle has a larger radius, right? So therefore, R is equal to 6 centimeters. So the radius of the bigger circle is 6 centimeters. The radius of the smaller circle, slightly bigger one, is 3 centimeters, and the smallest is 2 centimeters. Then you're done with mathematics completely.